Lesson 5-8, Graphing and Solving Quadratic Inequalities. So far, we've only been solving quadratic equations, and the ways we used to solve quadratic equations was graphing, factoring, completing the square, or using the quadratic formula. And those methods still work for solving quadratic inequalities, but the difference is with an inequality, we're looking for solutions that are greater than or less than a particular solution. So here's some things that you have to think about when you're graphing these inequalities. First of all, is your line solid or dashed? And we're graphing parabolas here. So a solid parabola looks like this, and you would only graph it solid if you see a little equal to underneath your symbol, like greater than or equal to or less than or equal to. And you're going to make your parabola dashed like so if you see strictly less than or strictly greater than. So ask yourself the question, is your line solid or dashed? And then do you have to shade inside or outside of the parabola? Now you're going to shade, I guess, I like to think of it as above or below, not really inside or outside. Let's say that your symbol is greater than or equal to. Well, if your parabola is a regular U-shaped graph, you're going to shade above the parabola or inside the parabola. If your parabola is upside down, now greater than means shade above the line, and so you're going to be shading outside of the parabola. Let's say your symbol is less than or equal to. If you have a regular U-shaped parabola, now you're going to shade underneath the parabola or outside of it. And if your parabola is upside down, now you're going to be shading underneath it again, so you're inside. So I still like to think of less than means shade below, and greater than means shade above. Here's one that we can try. So we're going to graph y is greater than negative x squared minus 6x minus 7. Now if I had a graphing calculator, I would just type this in, and remember that if you scroll all the way to the left of y equals, you can actually put in the greater than sign and have the calculator show the shaded region for you. I don't really have a graphing calculator right now, so I'm going to do this by hand, and I'm going to create an x and a y table. So let's just say I pick the x values -5, -4, -3, -2, -1. And if you had a graphing calculator, you could definitely figure out these points. The y values are -2, +1, +2, +1, and -2. So here's some points that are on the parabola. You can see that -3, 2 is the vertex. And I know this because my y values are symmetrical around that point. Okay, so let me put these points on my graph. -3, +2, there's the center. -5, -2, -4, +1. I guess I didn't go in order. And then I've got -2, +1, -1, -2. And actually, if I wanted to go 1 point further, I know that -7 is my y-intercept. Okay, so here's the parabola. It's upside down because I have a negative x squared. Those are things we know. Because of the symbol, it's strictly greater than, I'm going to make this parabola dashed. Alrighty. And finally, I need to do the shading. It says greater than, y is greater than that quadratic equation there. So I'm going to shade above the parabola. It's a pretty big shaded region. Everything above the parabola gets shaded, and you can do this however you want to. I suggest that you try this on your calculator so that you can also learn how it works on your calculator. Okay, so that means that everything above this parabola or in my shaded region is a solution to this inequality. Okay, now how can we use this idea of graphing quadratic inequalities to actually solve them? Find the areas or the solutions of the graph. What x values represent the solutions? Well, in this case, I kind of broken up into less than or greater than. So let's say that your equation in standard form here, ax squared plus bx plus c is less than 0, or less than or equal to 0. What you want to do is graph the parabola and identify the x values for which the graph is less than 0. And it's less than 0 right where I've highlighted here, where the graph is below the x-axis. These are the y values that are less than 0. So if in this first case, you would write your answer in interval notation from x1 to x2. Those are the x values that give you a graph below 0. If your parabola is upside down, like in this case, your shaded region or your solution region actually goes to negative infinity and positive infinity. So your answer in interval notation would be negative infinity to this x value, and then this x value to positive infinity. And the only difference is if you had a equal to under your symbol, you would use brackets instead of parentheses to show that you're including those x values. So these would be the graphs for less than and how you'd want to write your answer. If you see greater than ax squared plus bx plus c is greater than 0, you want to identify the x values for which the graph is above the x-axis. Where is your graph above 0? So again, I've highlighted the parts of the graph that are above 0. If you see a greater than in your equation, in your inequality, these are the x values that you would want to choose. You can see down here on the graph, if the graph is upside down, now greater than would represent this top part of the graph from x1 to x2. And if you have a regular U-shaped parabola, the greater thans are going to the infinities, negative infinity to x1 and then x2 to positive infinity. So let me show you how this works with an actual inequality, and it might make more sense. So we're going to solve this one by graphing, and what I would do, like any of these, is type them into y equals on my graphing calculator and then graph the points. Now you want to be very, very accurate when you're graphing these. So let me just give you some values that are on this graph. First of all, the one thing that I really want to know is I want to know where the zeros are. I need to know where the roots are of this quadratic equation, first of all. So the two roots are going to be at -3 and +1. -3 and +1. And the vertex of this graph, let me see here. Let me just quickly find this vertex by hand. We're going to take -b over 2 times a. So that's -2 over 2, or -1. And then if I plug in -1, I can figure out the y value, my vertex. So I'll get 1 minus 2 minus 3, and that's -4. Okay, so -1, -4, there's my vertex. So let me just draw on a rough sketch here of our graph. Now notice I'm making it dashed. Doesn't really matter here because I'm not too concerned about the graph as much as I am the solutions. So this is what our parabola looks like. Again, you can get this using your graphing calculator. I'm going to switch colors now so that I can show you which part of the graph here represents our solutions. So I want the x values that are, the y values, sorry, that are greater than 0. Well, greater than 0 means above the x-axis. So usually what I do is I just kind of color them in. If you want to make squiggly lines, you can, or color them in. These are the values that are above 0 or greater than 0 on my graph. Notice they're going to negative infinity and positive infinity. So now when I write my solutions, I'm going to say that the solution part of this graph is from negative infinity to -3 with a parenthesis because we're not including that endpoint. There's no equal to under here. In union with, then my next root is at 1, and I know that this shaded region will go to positive infinity. So what x values give you the graph, I guess, that's above 0? And it's from negative infinity to -3, and then from 1 to positive infinity. Those are your solutions, by the way. That's what you would write. Okay, last one. Now this one's written kind of weird. You want to make sure that's in standard form, meaning that the quadratic part is first and then the symbol in the 0 should be on the right side. So I don't like the way this is written. You should always rewrite it so that you've got 3x squared minus 7x minus 1, and then you want 0 on the other side. The question is, which way does your sign go? Well, right now it's pointing to 3x squared, this whole side, so, and it opens up to 0, so actually you need to flip the sign if you're going to rearrange your equation. So 3x squared minus 7x minus 1 is less than or equal to 0. Let's take a look at what that graph looks like. So this one here, if you try graphing it and you look for your intercepts, it's kind of hard to tell where they are because you don't have specific values for your intercepts. And I know this because I am looking at the graph right now. So what you have to do is you have to find those zeros using the quadratic formula. Okay, we have to use the quadratic formula, or you could use completing the square, but the easiest way to do this one would be using the quadratic formula. So let me just go ahead and find our solutions, our x values quickly by doing that. We're going to take the opposite of b, which would be -7, I guess, or +7 if we fix that, plus or minus, under the square root sign, b squared, that's -7 in parentheses squared, minus 4 times a, which is 3, times c, which is -1. And then we're dividing that entire thing by 2 times 3, the a value. Okay, so let's just simplify this quickly. We've got +7 out in front, plus or minus. Under the square root sign, we're going to end up with 61. And I'm pretty confident that there's nothing that will go into 61 here. That's a perfect square. So that is already simplified. And then on the bottom, 6. Okay, so these are the two solutions, 7 plus the square root of 61 over 6, and then 7 minus the square root of 61 over 6. And just so that I know where to graph it here, I'm going to approximate these. So you would type these into your calculator and figure out the two solutions. So one of them appears, if you use the plus sign in the numerator, you'll get 2.47 to 2 decimal places. And if you use the minus sign, 7 minus the square root of 61, and then divide that answer by 6, you'll get -0.14. Okay, so here's what our graph actually looks like. Here's one of the zeros, 2.47. Here's another 0. The vertex, I'm not really sure where it's at. I'm not really going to try so hard for that. Let's just say it's down here somewhere. This is what our graph looks like. Whoa. I'm not very neat with this tablet, but there's our U-shaped graph. Okay, there's the parabola. And we know where these zeros are located because I found them using the quadratic formula. Okay, you have to do that if your calculator doesn't give you exact roots. Okay, now the question is, where's this graph less than or equal to 0, below 0? Well, if I look on my graph here, it's actually right here. Where's the graph underneath the x-axis? Pretty easy to tell. Below the x-axis, we're looking at this little u right here. It's actually in between these two x values. We're not going to -infinity or +infinity here. The x values are in between these two solutions. And so if I were to write my answer, one way to do it is we could say, if we wanted to use our exact roots here, we could say x is in between. We can include them with the endpoint here because the symbol has an equal to underneath it. 7 minus the square root of 61 over 6, and 7 plus the square root of 61 over 6. This would be, I guess, an exact way to say your answer. If we wanted to use interval notation, you could put it in parentheses and say 7 minus the square root of 61 over 6, and 7 plus the square root of 61 over 6. Okay, so either or is fine. I guess I prefer interval notation. It's easier for me to read. And then also, if you wanted to just give approximations, you could say we're in between -0.14 and 2.47, approximately. Okay. All right. I'd like you to try this next one on your own. You can type it into your graphing calculator, see if it gives you the exact zeros, and then write your solutions in interval notation.